Okay, so let's work another problem off the stoichiometry worksheet. Let's go down to, let's say, problem 4. How many grams of sodium oxide are required to produce 1.6 times 10 to the 2 grams of sodium hydroxide? And here's our equation here. This is what we're looking at. We want to take note of our coefficients. These are understood to be 1. And there's a coefficient of 2 on the product side of the equation in front of the sodium hydroxide. Okay, now we're given grams here of sodium hydroxide, and we're asked for grams of sodium oxide, but we can't work in grams, not yet. We need to convert out of that to moles so that we can make comparisons between these different compounds. So we need to take let me get this on camera, there we go, 1.6 times 10, 2 grams of sodium hydroxide to moles. We've got to figure out how many moles that is. So let's find our molecular weight of sodium hydroxide. If we look at our periodic table, our sodium is 23. So I'm going to put it here, there we go. Sodium is 23, I hope that's not too small. Our oxygen, look at our periodic table, 16. Our hydrogen is just 1, which means the total molecular weight of the sodium hydroxide is going to be 40 grams per mole. Now, we're given grams. We're told this is how many grams we have of the sodium hydroxide. We want moles. So this is what we're going to do. We're going to take our grams, and we're going to convert that to moles. This is going to give us what? We're going to have 1.6 times 10 to the 2, which is really just moving the decimal point over, but I'll go ahead and use the exponent, divided by 40. It's going to give us 4 moles. We have 4 moles of sodium hydroxide. That's what we're given. But we want to know how many grams of sodium oxide are required to produce the sodium hydroxide. Well, let's go back and look at the coefficients and the ratios here. We know that we're going to need 1 mole each of sodium oxide and water in order to react and give us 2 moles of sodium hydroxide, which would mean that for 4 moles of sodium hydroxide product, we would need only 2 moles of this sodium oxide. 2 moles. Our product is 4 moles of this sodium hydroxide, which is twice this 2 moles given. So we would only need half of that to get just 1 mole here. So that's our ratio. So we're going to go with 2 moles of the sodium oxide. That's going to be required to get the 4 moles that we figured out here of the sodium hydroxide. 2 moles of sodium oxide. I'm going to draw a little line here, try to separate. There's not a whole lot of room to work on this paper. So to get from moles to grams, we just need to figure out what our molar mass is of this sodium oxide. We know that sodium, each sodium is worth 23 grams per mole. So we're looking at 46 already, plus 16. So we're looking at 62 grams total, right? 23 times 2 plus 16 gives us 62. So I'm going to write 62 grams per mole. So what we're going to end up with is what our 2 times 62, 2 moles times 62 grams per mole, gives us 124 grams of sodium oxide. Now, since we were given our original grams of sodium hydroxide in this notation here, we can convert our answer back into that standard notation. And there we go. 1.24 times 10 to 2 sodium oxide.